Thank you very much for having me. In this talk, I am going to show you what we've been doing in the School of Psychology at the University of Glasgow for the past few years. So my name is Emily Nordmann. I'm a senior lecturer in psychology. I just got promoted, and that's the first time I've ever got to say that, so I really wanted to say it. But I am part of the PsyTeachR team at Glasgow that many of you are already aware of. And in this session, my main aim is to convince you that despite the focus of today's talks, that the R in PsyTeachR is actually for reproducibility, and that it's reproducibility that should always be the driving force behind any curriculum changes rather than focusing on the tool that we're using. So just to focus on the tool that we're using for a couple of slides, here's a very brief overview of what happened at Glasgow. So from about 2010, our MSc level stats course was taught in R. But in addition to this, our third year undergraduate students were given the option to do their stats course either using R or using SPSS. And this was predominantly led by Dale Keep It Maximal Bar. I should also highlight at this point, given that we're talking about curriculum maps and so on, that of course the University of Glasgow is in Scotland, and the Scottish degree structure is different from England. So we have a 4-year degree where level 1 and 2 are pre-honours, and level 3 and 4 are the honours years. In late 2015, the first staff training session was held with an eye to, upskilling staff to a wider curriculum change to R, and by 2017-18 the switch had been made fully, although there's obviously been a lot of work done since then on the materials and the approach and so on, but we are now in the position where we teach all of our core undergraduate programs using R, as well as our 1-year MSc conversion programs, and also the data skills component for our research methods MSc. And as Andy has already said, staff training is not something you can do once. We tend to offer it at least yearly. I now tend to lead that training. It is something that does require, it's not just a one-off. I should also highlight that I joined the PsyTeachR team in November 2018. So in many ways, I am standing on the shoulders of the giants who did a lot of the, the really difficult transition work before me. So rather than focusing on the initial process of moving to R and risk being attributed credit for something I did not do, in this session, I'm going to give the perspective of a program where R is fully established. Because I think it's important not to consider just the startup issues you might have, but sustainability and deeper discussions about pedagogical approaches to teaching R, not just whether or not you're going to teach it. I'm not going to dwell too long on the technical stuff. Happy to take questions about that at the end, and all the materials are available online. But briefly, so all of our materials, as I said, are online, and we publish them using Bookdown, so they're custom books. We use the Tidyverse rather than base R, and we also use R Markdown and R Studio, which isn't hugely surprising, but we really have tried to integrate them into the teaching material. So it's not just the coding, we do take advantage of Markdown being a reproducible document of the features that R Studio gives us as well. We also do have the R Studio server. I have to say that I think it's a really good plan B, but if we're interested, I have had some issues with it this year, and I'm increasingly of the opinion that actually getting students to install on their own machines is worth the initial hassle, but we can argue about that later. We also use real data sets wherever possible, open data sets from published papers if we can, so that the data sets students are working with are real and messy. From a pedagogical perspective, both distributed practice and retrieval practice are embedded throughout the course to promote learning. So for distributed practice, what this actually means in concrete terms is that we build up their skills and confidence by repeated practice of the same functions. So particularly when it comes to data wrangling, there are dedicated chapters of the the book about data wrangling. But it's not the case that once they're done with those, that we move on. Every single chapter, no matter what they're doing, we re-emphasize the core data wrangling skills, because it's those ones that really are the hardest to master. In terms of retrieval practice, we've got a number of small stakes assessments that I'm going to come back to in a bit, but we also have retrieval practice built into the books using the WebEx package. So this very easily allows you to add in multiple choice questions or fill in the blank type questions throughout Bookdown. You can see an example of this on the screen there. So just constantly trying to test the knowledge and using retrieval practice to our benefit. Finally, there's also quite a lot of support. So we have our graduate teaching assistants that play a really big role in helping our students with R, but we also use live coding and walkthrough videos to support the beginner learners. The walkthrough videos came in the last year when Glasgow was completely online for the entire year. And they're scaffolded to the level of the students. So for level 1 students, they get full-on live coded walkthrough videos for each chapter of the book in the first semester. This is then dropped to every other chapter in the second semester. Then in level 2, rather than walkthrough videos, they get these kind of like 5-minute summaries of what the chapter is going to entail, some kind of hints, things to look out for, and so on. And then from level 3, they're on their own just with the written materials. For the conversion course students, the MSCs, they get walkthrough videos for every chapter of the book because they have a compressed time scale, but also the diversity of that cohort and their understanding of the degree program they've actually signed up to. It does require a slightly different level of support. Okay, so happy to take any questions about what we do, but now I want to move on to the why. So given the audience that's likely turned up to this talk, I am not going to waste my time and yours by telling you all about this thing that happened called the Replication Crisis. I'm going to assume that at some point it caught your attention in the last decade. The causes of the Replication Crisis have been discussed at length, and one of the issues, of course, is that it's not just about replication. It's not just about dejuxtapel or questionable research practices. It's about the way that psychologists have been trained to work with data from our very first stats lecture. And that actually, before we get to issues of replication, we may want to look at the issues we have with reproducibility that arises because of the way we teach and we're taught stats. Traditionally, the focus of psychology, stats and research methods courses has been on the end product. We assess the report or the dissertation that students produce. We also do things like give them stats exams on the models they're learning about, and we focus on them understanding which numbers from the output that they need to worry about. There is a really strong pedagogical literature that says that students are assessment focused, not only in terms of what they spend their time working on, but what they then consider to be important. So it should come as little surprise that for the past however many decades, we've been churning out graduates that think the most important bit of the process is the end product, because that's what we've marked. You can have no idea what's really going on with the data or what those buttons you clicked actually did. But if you can pick out the right numbers from the output and write it up well, you will probably get an A. That focus has led to a real knowledge and skills gap in our psychology graduates. And typically there's been relatively little time devoted to things like data cleaning or structuring, transforming data, despite the fact that, as Andy's already talked about, these steps are extremely time consuming. They're what we as researchers spend a lot of our time on, and they're complex and prone to error. And this manifests so clearly when we look at our final year dissertation students and what they're able to do and what we do for them. When I look back at what I used to do for my dissertation students in my previous institution where we used SPSS, I feel a genuine sense of shame. They would run their experiment in ePrime or whatever, and I would take all their data files and I would do the processing for them. I would take all the raw, messy, individual data and I would turn it into this cleaned, aggregated data set that they could run their stats on. If I was feeling particularly revolutionary, I would walk them through the steps of what I had done, but they wouldn't do it themselves. I feel shame because that experience taught them little of actual use. I didn't teach them to be able to go and work with data themselves, because no real data they would ever encounter would be ready to go in the way the data was that I'd been giving them. And it also led to kind of really small scale issues of reproducibility, whereby I would run the stats and they would run the stats and they would be different. And I'd say, well, what did you do? And of course, they couldn't remember which buttons they had clicked in which order. But it also led to self-efficacy issues, which is that they had come into their dissertation or their MRes or whatever, thinking that they were good at stats and that they were good at working with data because they had done well in their stats exams. They had worked through all of their point and click worksheets with the nice data sets that we'd given them. And then they'd be handed this real data set and they would just melt. And they would attribute it to them being bad at stats, rather than attributing it to the fact that they were never taught how to work with data properly. As a field, we have historically been guilty. We don't tell our students that the bottom of the iceberg exists. So they fire up the engines, then suddenly Kate Winslet is on a plank of wood in the middle of the sea, and it's all gone very wrong. So there are two components to how we address this problem. The first is data skills. And the second is about embedding reproducibility and open science into the curriculum at every possible point. I'm going to give a brief overview of the entire curriculum, and then I'm going to go into detail on two courses, which is the Level 1 course and our MSc Conversion programme, because those are the courses that I have helped lead and develop since I moved to Glasgow. So here's the overview of the undergraduate data skills and stats curriculum. In Level 1, we focus on getting them comfortable with R. So they do some basic data wrangling with descriptive statistics, they do simple visualizations, but we also introduce the concepts of probability and distributions, and we use some very simple simulation and probability functions in R to get them feeling more comfortable with this. And Level 2, we then introduce inferential statistics, but again, with this strong focus on probability and the underlying model. So the course covers permutation tests and the GLM, but it also does more advanced data simulation and visualization. Level 3 then moves on to mixed effects, again with this really strong focus on simulation. And there's also a bit of psychometrics. And then in Level 4, students get to choose their elective courses. So there's more advanced stuff. So for example, there's a course on bootstrapping. What I want to highlight with this is that often when I talk about what we've done at Glasgow, particularly when I talk to colleagues working in English institutions, the response is, oh, well, you have that four-year degree. You have the time to slow things down at the beginning and get them used to coding. We don't have the time. And, even in Scottish institutions, people are like, we've got the BPS accreditation to teach. We don't have time for this. And I used to accept this argument, but I've become slightly more belligerent in my old age. And I now have 3 responses to the suggestion that you can't teach R because we don't have the time in a BPS accredited curriculum. First, our stats curriculum at Glasgow goes beyond what a lot of curriculums that are using SPSS cover. This may well not be true, particularly of the people who have turned up today, but it is the case for a lot of institutions, that they don't do mixed effects models. They're not doing bootstrapping. They essentially cover what we cover up until the end of Level 2, which is absolutely fine and is what is needed for a BPS accreditation curriculum. But do not tell me that you don't have time, because my second response is that you make time for what you consider important. It's as simple as that. And if you still don't believe me that you don't have time, then my third response is to bring out my conversion course curriculum. So if you haven't taught on a conversion course program before, they are 1-year postgraduate degrees where students with a non-psychology background essentially do the entire accreditation curriculum in the space of a year rather than over 3 or 4 years. They are challenging programs for students because there's a lot of work to do and a lot of knowledge and skills to gain in a compressed amount of time. And for staff, they're challenging because these cohorts are incredibly diverse beyond anything you've seen on an undergraduate class. I will have someone with a computing science degree who is better at programming than I am, And then I'll also have a fashion graduate who doesn't know how to calculate a mean in the same class, both learning R. Because of this, we take a slightly different approach to the conversion course from the undergraduate programme, in that we cover a more limited range of stats, and they're taught with a more traditional slant rather than going full GLM. But it's all still in R. They go from installing R, most of them never having done any stats or programming in their life, to running reproducible regressions and power analyses in the space of, I think it's 14 weeks of teaching the quantitative content. And I truly believe that we're able to do this because what we highlight to them isn't the stats of the tool, it's reproducibility and the skills that they are learning. As far as I can find, although I suspect I will be very quickly corrected if I'm wrong, I think that it's just us and Plymouth that teach conversion course students using R. And I remind my students of this frequently, that they have a skill that almost every other conversion graduate doesn't, and the job market is fierce and they have an advantage. As I said, students care about what is assessed. So what you assess is what they will care about. So let me give a few concrete examples of how R and reproducibility is built into the programs using my Level 1 and MSc courses. So the main tool that we use for assessing students' R work is the Assessor package by Dale Barr. It doesn't fully automate marking and assessment, but it does make it much easier. So this year I had a first year class in the first semester of 670 students. And using this package, I was able to do the marking and feedback for all of them for each of their assessments it was about 5 to 6 hours. So there's still a time commitment, but 670 students, 5 to 6 hours, it's not bad going. Typically, the data skills assessments are small stakes. We want them to do little and often, and for them not to be afraid of failure. If these things go wrong, they have a low impact on their overall grade. So for Level 1 and for the MSCs, there are 3 data skills assessments in each semester worth 5% each, although for Level 1, the first one is formative. These assessments tap a range of skills, and in the last year I've been playing around with them and trying to expand the skills that we assess and therefore the skills that we're highlighting as important. So they start out very simple in Level 1, where they're really just asked to repeat what they've been doing in their weekly exercises and the book down materials. It's, load the tidyverse, load the data into these objects. They do start out very, very scaffolded, but there is still a focus on precision and reproducibility. So these exercises get them used to the fact that things like variable names and object names are important, R is case sensitive. And it also gets them used to using Markdown. So they're told to, knit their file as part of an error checking and debugging process that they should be constantly reviewing whilst they're coding. We then, as their confidence builds up, start probing different skills. So this is from the second semester of Level 1, and it's called error mode. So rather than asking them to write code, we give them code with errors in it, which they have to fix. So they have to debug the code. I did this year for the first time, and it went really, really well. And the feedback that I got was that it made them feel empowered. It made them realize that actually these error messages could come up and they were capable of fixing them, and that they weren't necessarily something to be scared of. But again, assess what's important. Debugging is important. We also then have a technical challenge, because I watched too much Bake Off, that's focused on visualization, and these challenges give them minimal instructions. So there's 2 versions of this. We either give them these kind of specifications here, so, create a bar chart that does this, with various different steps to it, or we give them the data and the plot, and we say, make this plot, so that they have to write the code. So we're focused on, can you replicate, can you reproduce an output? And then finally, we also use MCQs, actually just using the Moodle quiz function, to test their ability to read code. So this one is, which code will make this plot? So lots of little assessments, each trying to tap a different aspect, but all of them focused around reproducibility, transparency, and building their skills and confidence and mastery with R. In addition to the specific data skills assessments, the research projects they conduct are centered on reproducibility, and they put the focus on asking good questions in research design rather than the output. So at level 1, they don't just get a lecture on open science and reproducibility. Their main written assessment for the second semester is a registered report. They then analyse and present the data from the study that they've planned, working in small groups. But the way that the project is set up is that they have access to the small data set that their little group recruited. So, you know, it's on a good day, it's like 50 participants, but it's normally about, 20, 30. But then they also have access to the data set the entire cohort collectively recruited, which runs to several thousand participants. And rather than calculating p-values, their job is to put all of those data wrangling and visualization skills into action, and to present descriptive statistics and visualizations, and to talk about how the data are different between the big sample and their small sample, as well as how different kind of visualizations change the conclusions you might draw, i.e. bar graphs are terrible. But it's all real messy data that they're using to do this. For the MSC Conversions, they spend most of the first semester working on a pre-registration in a group for their quantitative project. And this has the added benefit that it allows them to kind of progressively apply what they're learning in the theory lectures and the stats lectures. So they build up the pre-reg as their knowledge builds up. So when they're first learning about the basics of experimental design and research, they start with a literature search and formulating their hypotheses. And by the end of the term, they're tackling the power analyses. They then write up the results of the study in an individual quantitative report, but the focus is on transparency, not the results. They're told, you can explore your data. Are there any deviations from the pre-reg? And so on. So it reinforces the idea that there's exploratory and confirmatory research and how to accurately represent what they did. But yeah, the pre-registration is entirely done in R Markdown. That's what they submit, and the marking criteria explicitly rewards them for producing a reproducible document. I have one more slide. Sorry, I'm aware I'm slightly running over. The key thing about all these assessments is that R is just the tool that we use to achieve our goals. Most of what we do could arguably be done with Excel or SPSS if you use syntax and formulas and so on, although it would be much more difficult. The data wrangling and the visualizations particularly, I don't know how you would achieve those reproducibly without a script language. But I do think it's really important that when we're talking about teaching R in psychology, we don't encourage people to teach R in a vacuum. If you make no other changes to your curriculum, if you're going to, take your point and click worksheets and your sanitized data sets and you're just going to rewrite them in R, there's no point. I can assure you that there are more fun ways to inflict pain on yourself and other people. There was a tweet that got a lot of attention a couple of weeks ago. I'm not going to screenshot it because I don't want to be that person, and I actually really respect the person who wrote it. But it said, "When I see problematic psych papers, I've never thought I wish these researchers knew R. The problems typically involve basic research, design, measurement, understanding of stats, and inappropriate inferences. Maybe we should just focus our limited time with students on those." And that tweet just made me sad because when I look at our curriculum, that's what we're doing. Using R as our tool facilitates it. When I stopped being sad, I did have a more cynical moment. And I thought, well, if it is completely possible to instill these values and develop these skills using SPSS, why does no one ever seem to achieve it? But the point remains, if we're going to improve psychological science, we need to improve how it's taught from the ground up. And to do that, we do need R, but the R is for reproducibility. Sorry for going over. Thank you so much to the SciTeachR team and everyone who came before me and did all the work. And yes, I look at the chat now. Right. What am I doing?
Thanks, Emily. That was fantastic. So we've got a couple of questions to fit in. before we move on to Andy's talk. So there's a question about assessments and how the various assessments, and in particular is it called Assessor? I've never come across that before. Assessor package. How does that work, and how does it sort of fit and feed into your general university, marking tool?
So the way that Assessor works is that because it's done in Markdown, it compares what is in code chunk T01 in the student's file with what is in code chunk T01 in your solution file, and it compares them. And the way that the marking is done is that you don't have to go through all the responses. You just kind of review the incorrect responses, because obviously occasionally there's some way in which they have done it correctly, but they haven't done it in quite the way. So we do review. There is a human that reviews all of that, but then the feedback is automatically generated by the Assessor package, and it works. It's integrated with Moodle. So the package allows us to upload, to download all of the scripts from Moodle, and then we can just upload a zip file of feedback to Moodle. It's just using the tools that Moodle has in place, and then again a spreadsheet with their student IDs that links their grades. So it's somewhat outside of the usual university assessment processes, but it does still fit into them. We're not having to kind of change any systems, really. It's just a slightly different use of them.
Great, thank you. And then we had a question about how you sort of prepare students for these sorts of assessments, with the way you're giving some minimal instructions and scaffolding. How do you sort of build up their confidence to find solutions to those things? And Lisa responded with a sort of point about the live coding sessions. Do you think that's key to, showing students how you sort of problem solve in these situations?
Yeah, so it's not just one thing. There's a few things there. Whenever we do the live coding, either in the walkthrough videos or in class, I make a point of I never prepare. I always go in blind, and I try and force myself to make errors. So I think that modeling of just everybody makes mistakes is part of it. But the first semester is really, they're getting comfortable with it. So there is a lot of time spent on, just getting them to feel confident with what they're doing. But also I explain everything. So the assessment information sheet for the second semester things basically says, right, this is what you can do. Now we're going to try and test these skills. And so we give them very explicit information about why we're doing what we're doing, but we do have the GTA support sessions, so they can book in, every week if they want, and just get that little bit of individualized one-on-one support with one of our graduate teaching assistants. I've also added in, I just did this this year, was that I have added in, let me just share my screen, debugging exercises to the book. So it basically it gives them exercises to do that will create errors, and then it gives them a solution. So the loading data and stuff like that. So I do try and model and again build that into what they're doing, that they feel comfortable with it. But we also have things like we have peer assisted learning as well, where students can get help from other students and so on. I'm not going to lie and be like all 670 students like that. Of course they didn't. There's the ones who come in and they're here to talk about Freud and their dads, and that's never going away. But like when you see what they're capable of, particularly with that presentation where they can wrangle the data and compare the distributions and everything, like those are level 1 students. Some of them are still 17. They're in Scotland. Like it is. It's astonishing what they're able to learn. But I also, a huge part of my teaching for both level 1 and the MSc is there's no such thing as what a programmer looks like. And particularly for a very female skewed degree program, I think it's really, really important to empower students to be like, just because you're not the kind of programmer that you see on the TV doesn't mean you're not capable of it. And I think that's a huge part of my job, is to give them the confidence to get those skills, because it helps their employability so much.
Yeah, I'd say just a sort of personal experience on that. We've really struggled with that this year. These students coming in and not sort of accepting that they're at the very start of this journey, and that, you know, we're really struggling to communicate to them that it's absolutely okay to feel like you're feeling right now, that it's all a bit uncertain, and you know, we understand that this is all new and it's completely out of your comfort zone, and that, but trying to sort of get to them that, don't worry, you're going to practice this stuff every week, you know, and by the end of the year you'll be where we want you to be, and they are, but they can't handle that sort of that fear that they have at the start.
It's one of the reasons why the second semester they now do this report with their own data, because I wanted to give them some ownership, or, you know, to be excited about looking at it, but I also didn't want them to care about p-values. So hopefully I found a way to strike that balance.
Great, thank you, Emily. We'll move on to Andy's presentation now.